Hello, and welcome to an episode of ES Repair. I am your host, Mr. Fix-It. In this video, I'm going to demonstrate how you can test a typical ATX form factor power supply unit for your PC. Now, it's not hard to test. It's a good thing to know if your new one is working good. It's also good to test your old one if you're having problems with it. I will also identify all these plugs so you'll know which plug goes to what component. So let's get started. Here is a typical power supply. This is one of my new ones that I've had to replace in my main computer. This one here is an 800 watt capacity. Now they make these as high as 1,000, and I think they have one that's 1,500, which is a mighty big power supply. Now, when you open these up, I'm going to show you the different parts of the cables, identify which cable, which plug goes to plug. But first, this is a total power. It shows your AC input for 115 or 230. Some power supplies do have a switch on the back of them to where you can flip it. Be sure you're using the correct switch setting depending on your location. Some of these do not have a switch, meaning that the power supply automatically detects the voltage incoming. The frequency is either 60 or 50. And the input current here is 8 amps for the 115, and it shows you that it's 5 amps for 230. And it shows you the amount of current that the power supply will draw based upon the input voltage. Now below that you have your AC input, which it shows it's 115 or 230 in the frequency. Below that is your DC output. Now this is what you need to keep an eye on. These are known as rails. You have the 3.3, a 5 volt, a 12 volt, another 12 volt, and a negative 12 volt, and another positive 5 volts. Now, most of these newer ones only have one negative rail. The other ones had two, but the 5 volt one was discontinued. Now, this in here is ATX version 2.0 and higher. And there's been some moderate changes between them, which I won't go into right now. But as you can see, for each rail, it gives you the amount of current that each rail can provide. For example, here it says positive 3.3 volts. It says 25 amps. 5 volts, 28 amps. Now this is the amount of current that each rail will provide. Now notice there are two voltages, or two rails for 12 volts. One's labeled V1 and the other one's labeled V2. That means there are two separate 12 volt rails. Each one of these is a rail. Now, down here in the bottom it shows you this is a maximum continuous wattage. that this power supply can provide. Now, again, you have your other side, which you have your voltage selector switch. Be sure you put it on the correct setting. If not, you can damage your motherboard. You got some of these have power switches, and of course your power cord. And then you have your cooling fan. Now, once you have an understanding of this, compare it to your old power supply. The old power supply will have the same label as this, but your new power supply must be equal to or greater than your old one. It's okay to have a stronger or a more powerful power supply, but do not replace it with a less wattage power supply because you can burn it up. But bigger power supplies are okay. Now, what we're going to do is I'm going to show you how to test these. Now, first, I want to show you which plug are which. Let me get that one out of the way. These are the SATA connectors. As you can see, it's got the small flat edge with an indentation here. These are for the SATA drives. These power all SATA drives. This one here has 3 connectors on one cable. Now, to see all these, I'm going to show you later. As you can see here, it says SATA. That's to help to identify that this is for a SATA drive. These are the power connectors. As you can see, it got an orange, a black, red, and yellow wires. Another one we have is the P4 connectors. These were used for the Pentium 4 processors. Now, you'll see a little square connector real close to the main processor, and that is where this one connects. Some of them that have dual processors, which are physical 2 separate processors, this one here can provide each processor. Some of the boards have 2 of these. These are just P4 connectors. These were introduced after the Pentium 4 processor. Older processors used the 5-volt power supplies and realized that it was drawing more power to operate these processors at such high speeds. They were introduced with these, which provides 12 volts instead of 5, to where it can consume less power. So these are the P4 connectors. Next we have, you've seen the SATA ones. Most of these will have 2 of these sets, 3 for each line. Another one we have are the IDEs. These are used for IDE drives. Some of these will also show you the voltages that each one goes to, as you can see here. But these are for IDE drives, whether they're hard drives or optical drives. Now, keep in mind that some older versions of the AGP video cards, such as NVIDIA's, also use these types of connectors. Another connector you may see, which are becoming obsolete, are the floppy power supplies. This fits a floppy drive, and these are being discontinued because not very many computers have floppy drives in them anymore. So don't be surprised if you see one or if you do not. They're not used except for floppy drives, which are like the 3.5 inch and the 5.25 inch drives. Again, you'll have other connectors. This one here has 3 per line. It also contains the red, black, and yellow, which I'll explain later. And as you can see here, some of these are connected to the IDE connectors. Now next we have, if I can separate the two, there we go. This you may not see very much. Now what this is a PCI Express connector. This is for graphic cards on the high-end versions. And what it is a 6-pin mini fit junior Molex connector, as you can see here. And these are specifically for video graphic cards on the PCI Express. Now this also has an adapter because some models use the 6-pin, which is this one, and some of them use 8-pin, which this will attach to this to create a 6-pin plug. Now the motherboard, or not the motherboard, the video card only uses 2 of the yellow wires. The center one isn't used most of the time, but power supplies, as you see here, often include the third 12 volt. And that is specifically for the PCI Express video cards. Now, the last one I'm going to show you are the motherboard connector. Now, this here is your typical motherboard. And now, as you can see here, there are 20 pins. This is what powers the complete motherboard. Now, you'll notice this piece right here. This is a detachable piece. As you can see, I can remove it. Now, older motherboards use this type, which is a 20 pin. And the newer ones are 24 pins. Now, this one here allows me to use this adapter to be either on a 20 pin or a 24 pin. Now, if I want to use it in a 20 pin motherboard, all I have to do is remove that and I can plug it in. Now, if it's going to be used on a 24 pin motherboard, then all I have to do is attach the additional 4 pins, like so. And that's how you do that. And of course, you got your latch. This here added more power to the motherboard to where it can be supplied. And that's all this for, this extra one was called. You may know this as a 20+4, and it relates to this. That's what these types of plugs are identified as, because they're universal. You can plug it into a 20 or a 24 pin motherboard. Now, the next thing I want to show you is the voltages for each wire. Now, the red wires, as you see here, that provides 5 volts positive. You got the orange one, which is 3.3. You got the blue one, which is a -12. You've got the yellow ones, which are 12 volts, as you've seen on here. These are 12 volt yellows. The blacks are grounds. And I'll show you how to turn these on, because what I'm going to do is show you how to test your power supply. Now I'm going to show you how to test these power supplies. Now, it would be a good idea to test a brand new power supply if you're having to replace your old one to ensure that your power supply is working correctly. You don't want to put a defective power supply in your computer because it can seriously damage your computer if it's not working right. Now, you can test your old ones, which I'll show you here. The best way to do it is what you're going to need your motherboard connector, as you see here. You'll need a small wire. A solid wire works best. Now, what we're going to do is you're going to take this green wire that you see here, that green wire there, this is the power on. This is what we're going to use to turn on the power supply. To do that, we'll need to ground it out. Now there's ground wires, all the black wires, any of them would work. So to do that, you'll notice what I'll do. You'll locate the green wire. In this case, it's the fourth one from the left, as you see here. And I'm going to ground it to the black wire next to it. And then move it out of the way. Notice that my fan turned on. This means the power supply is on and it's operational. Now we can check the cords. Now take your black probe, connect it to a black wire. So this will be ground, like so. Now you can test your other ones. The yellow one is 12 volt. As you notice on the meter, it says 11.7. Let me turn it around. Now, that'd be easier to see. Now, notice it says 11.72. Next one to it also says 11.72. Check the red one, which is on the bottom here. There we go. See, it says 5.2. Now we can check the orange on this side of the plug. And it shows 3.4. Now when you're testing these, all your measurements has to be within 4%. Some power supplies give you 10%, others are more tightly to where they're 5%, which is a good rule of thumb as long as they're within 5%. The very high performance power supplies are usually around 4%. So to get the best results and the best power supply, be sure that the tolerance is within 5%. All you have to do is take 5% of the stated power supply, for example 3.3, and take the 5% of 3.3 and then add that to 3.3 and then subtract it from 3.3. That is your range that the power supply should be in. And then you could test all of your wires to make sure that the corresponding voltage matches the wire. Now remember, the orange is 3.3, the red is 5 volts positive, the yellow is 12 volts positive, the purple is 5 volts positive, your blue one should be negative 12 volts. And these are all the primary connectors. And this is how you turn on the power supply to check your voltages and stuff. Now, once you're done and everything checks okay, just simply remove the wire and now your power supply is turned off. And that is how you check and test to make sure that your power supply is providing adequate power to your computer. Now another thing that we can check on the power supply is the power good signal. Now the power good signal, which is this gray one right here, is also known as a power OK signal. Now what that wire does is it signals to the motherboard that the power supply is okay and it's stabilized, and it has to have a 5 volt signal in order for the power supply to turn on, or in order for the motherboard to turn on the power supply. Now to test it, we need 2 probes, your test meter. It needs to be within 3 volts to 6 volts. So what we need to do is connect the green wire, as you see here, to the gray wire over here. Now, do that, it can be a little tricky. You connect that one. And you should get around 5 volts. Now if you switch it, which is the gray one here, see, you should get around 5 volts. 5 volts is nominal, that's what most of these power good signals use, but it needs to be between 3 and 6 volts. And to trigger it, it has to be at least 2.4 volts. So remember, just use your red one on the green, the black on the gray, and you should get a 5 volt signal. Well, this concludes this video by ES Repair. I've showed you how to test your power supply unit from your desktop PC. I've shown you how to identify which plugs go to which components, and I've shown you how to test the connectors and compare it to the voltage requirements and the tolerance that the power supply must meet. Well, I'm your host, Mr. Fix-It. Thank you for watching.